Welcome to the DIY Honda Garage channel. DTC P0171 indicates that the fuel system is too lean, meaning that there is insufficient fuel in the air-fuel mixture sent to the engine for combustion. This issue can significantly affect engine performance, leading to issues such as stalling or poor acceleration. The DTC is particularly critical because it could lead to increased emissions and potential damage to engine components over time. The affected components often include the mass airflow MAF, sensor, fuel injectors, and the air-fuel AF sensor. It's vital to address this error promptly, as it can ripple into other systems such as the Vehicle Stability Assist, VSA, or emissions control systems. The DTC is confirmed when the fuel trim values or system performance are outside specified thresholds. DTC P0171 describes a condition where the fuel system is too lean. This means that the ratio of air to fuel is higher than expected, leading to combustion inefficiencies. The primary components involved include the mass airflow MAF sensor, which measures the amount of air entering the engine, the air-fuel AF sensor, which monitors the ratio of air to fuel in the exhaust, and the fuel injectors that deliver the required amount of fuel to the engine. The MAF sensor is usually located near the air intake, while the AF sensor is situated in the exhaust system before the catalytic converter. Proper functioning of these components is crucial for optimal engine performance and emissions control. There are several potential causes for DTC P0171 being triggered. One common issue is vacuum leaks in the intake system, which can cause an excess of air to enter the engine. A faulty mass airflow MAF sensor can also incorrectly calculate the air supply, leading to a lean condition. Additionally, fuel supply issues such as a malfunctioning fuel pump or clogged fuel filter may restrict fuel flow. Sensor faults regarding the air-fuel sensor and other relevant sensors can generate inaccurate readings, leading to erroneous DTCs. Thoroughly diagnosing each area can help to pinpoint the exact cause. Symptoms associated with DTC P0171 include a rough engine idle, which may occur due to an improper air-fuel mixture causing combustion irregularities. Drivers may also experience poor acceleration, which can severely affect vehicle performance. The check engine light, CEL, is often activated when this DTC is triggered. Increased emissions may also be observed, affecting environmental compliance and could lead to issues during emissions testing. If the vehicle displays any of these symptoms, it is crucial to perform further diagnostics to address the issue effectively. The first troubleshooting step for DTC P0171 involves verifying the problem at idle. Start the engine and allow it to idle in a safe condition, ensuring that automatic transmissions are in park or neutral, and manual transmissions are in neutral. Next, use the Honda Diagnostic System, HDS, to check the parameter known as AFFB, or short-term fuel trim. This value should be compared against a specified threshold of 1.33. If the value exceeds this threshold, the AFFB is indicated as too high at idle. In this case, you will proceed to step 3 for further diagnosis. If the value is within the accepted range, continue to the next verification step. In this step, you will review the onboard snapshot to check the parameters recorded when the AFFB was at its highest value. This process involves driving the vehicle according to the conditions that led to the high fuel trim reading and recording necessary values such as engine speed, vehicle speed, relative throttle position, REL-TP, sensor readings, and accelerator pedal position, APP, sensor readings. After collecting the data, Check the AFFB reading again with the HDS while driving under these conditions. If it is still above the threshold of 1.33, this step confirms persistent issues, requiring relocation to step 3. For this troubleshooting step, the first action is to turn the vehicle off to ensure safety during inspection. Next, you will need to remove the mass airflow, MAF sensor, and intake air temperature, IAT sensor 1, from their location. Carefully inspect the mass air sensor for debris such as lint, bugs, or any other foreign particles. These obstructions can significantly hinder the sensor's operation, causing incorrect readings that may trigger the DTC P0171. Should debris be found, it must be removed, and ideally, a vacuum cleaner should be used to clean the air cleaner housing area to prevent any recurring issues. If no debris is found, reinstall the mass sensor and proceed to step 4. The next step focuses on visually inspecting critical components for any signs of damage or disconnection. Components to inspect include the crankcase breather hose, air cleaner housing, and intake air duct, along with the oil cap and dipstick. Look for cracks in hoses or damaged fittings that could lead to air leaks, contributing to a lean fuel condition. If any damage or disconnection is noted, repairs should be made to restore proper function. If all components appear to be in good condition, you will then continue to step 5 for further investigation of the EVAP system. In this step, the focus is on the EVAP canister purge line. Perform a visual inspection of components, including the non-return valves and the EVAP canister purge valve itself. Look closely for any disconnected hoses, cracks, or other signs of damage. These components are crucial for maintaining proper fuel vapor control and ensuring that the air-fuel mixture remains balanced. If any damage is detected, those parts should either be repaired or replaced. If no issues are found, proceed to step 6 to check the positive crankcase ventilation (PCV) system. Continue to let the engine idle as you begin this step. Gently pinch the hose connected to the positive crankcase ventilation (PCV) system. This maneuver helps determine if there is a leak present in the PCV system that could be aggravating the lean condition. While pinching the hose, monitor the AFFB using the HDS to check if the value exceeds the threshold of 1.33. If the fuel trim indicates it is not leaking, proceed to the next step. If the valve does drop significantly, indicating a leak, check the hose for any visible damage or fissures and repair as necessary. In this step, the objective is to check for vacuum leaks in the intake manifold. Begin by toning the vehicle off and disconnecting the intake air duct from the air cleaner housing. Connect a large intake manifold adapter cone into the duct from the over-the-counter LeakMaster Evaporative Emissions System Tester Kit. Start the engine and allow it to idle while directing smoke into the intake manifold. Carefully inspect areas such as intake manifold gaskets, throttle body, air intake ducting, and all vacuum hoses. If any leaks are detected, they should be promptly repaired to restore proper vacuum pressure. After addressing any leaks, reconnect all components and proceed to step 8. This step deals with assessing the low-pressure side of the fuel system. It is crucial to measure fuel pressure under conditions when the AFFB reading is greater than 1.33. Utilize a fuel pressure gauge to ensure the readings align with the specification. If the pressure is within the acceptable range, move to step 9 for further inspection of the high-pressure side. However, if the fuel pressure is inadequate, check the power supply and ground for the fuel pump. If both are functioning correctly, but the pressure remains low, it might be necessary to replace the fuel tank unit. After turning the vehicle off, Switch it to the on position to power up all necessary systems. Use the Honda Diagnostic System, HDS, to clear the diagnostic trouble code, DTC. Start the engine and maintain an engine speed of 3,000 RPM without a load until the radiator fan activates. Following this, select the direct injection fuel pressure test in the HDS. This will validate whether the fuel pressure is within the normal range during operation. A normal reading indicates adequate fuel delivery, while any deviation from specifications will require looking into DTC P0087 and P0088 for further fuel-related concerns. For this troubleshooting step, start by turning the vehicle off and then back on to prepare systems for testing. Conduct the cylinder air-fuel AF test 3 times with the HDS under specific conditions. AC off and all electrical loads also off. This test checks the functionality of the fuel injectors. If any cylinder indicates a fail status, it's necessary to replace the entire set of injectors to ensure even performance and proper fuel distribution throughout all cylinders. If no fails are indicated, proceed to step 11. This troubleshooting step focuses on potential fuel quality issues. Begin by turning off the vehicle and draining the fuel from the tank completely. Refill the tank with known good fuel to minimize the chance of encountering contaminated fuel that can affect performance and cause a lean condition. Start the engine and operate the vehicle under similar conditions that previously resulted in an AF/FB reading exceeding 1.33. This helps to verify if the fuel was indeed the root cause of the issue. Monitor the AF/FB during this test. If the level now appears normal, the fuel was confirmed as the source of the lean condition. For this troubleshooting step, continue allowing the engine to idle while monitoring specific parameter values. Prepare to hold the engine speed steady at approximately 2,500 RPM by using the accelerator pedal accordingly. During this time, the engine coolant temperature, CET sensor, should be above 158 degrees Fahrenheit, 70 degrees Celsius, and it's essential to keep all electrical loads turned off. As the engine is held at this RPM, check the MAF sensor reading via the Honda Diagnostic System, HDS. It should ideally read between 4.1 to 5.7 grams per second. If the obtained MAF sensor reading exceeds or doesn't meet this range, the MAF IAT sensor should be further inspected for possible damage, incorrect installation, or even replacement if found defective. In this step, start by turning off the vehicle to prepare for component replacement. You will now replace the air-fuel AF sensor, sensor 1, with a known good unit to ensure functionality. After the replacement, turn the engine back on and conduct a test drive under the same conditions where the AF/FB value previously exceeded 1.33. Monitor the AF/FB with the HDS during this drive. If this value remains high post-replacement, it indicates that the AF sensor was not the root cause. Reinstall the original sensor before moving on to step 14. This final troubleshooting step involves checking whether the fuel injectors are contributing to the DTC P0171. Start by turning off the vehicle and then proceed to replace the injectors with known good injectors. After completing this replacement, start the vehicle and once again operate it under conditions where you previously noted high FB readings. Check the HDS for the FB value. Should it remain elevated, this indicates that the injectors are not at fault, prompting the need to substitute a known good powertrain control module, PCM. Conversely, if the injectors were the issue, confirm the performance by checking their output values reflect a normal reading. After completing all troubleshooting and repair steps, It is crucial to perform a final verification. Check for any stored diagnostic trouble codes, DTCs, in the Honda Diagnostic System, HDS, to confirm that none are outstanding. Monitor the AFFB reading once more to ensure that all values now fall within the normal operating range. If all parameters are back to standard, the system should now be functioning correctly. This verification process is important to ensure that no issues were overlooked and to confirm that all repairs are effective. It solidifies that the vehicle's fuel system is now operating optimally, ensuring that the DTC does not trigger again. To prevent the occurrence of DTC P0171 in the future, it is essential to implement regular preventive maintenance. Routinely inspect the fuel system for any signs of leaks or degraded components. Ensure that both the MAF and the AF sensors are cleaned or replaced as necessary, considering that dirty or defective sensors can contribute to inaccurate readings. Regular checks of hoses and connections for signs of wear will help prevent vacuum leaks, which are a common contributor to lean conditions. By keeping these components in good working order, you can enhance the reliability and performance of the vehicle's fuel system, potentially saving time and resources on repairs down the line. In conclusion, DTC P0171 indicates a fuel system that is too lean, which can lead to significant performance and emission issues. It is essential to address the potential causes like vacuum leaks and faulty sensors promptly. Following the outlined troubleshooting steps allows for a systematic approach to diagnosing and fixing the problem effectively. Regular preventive maintenance can help avoid future issues, keeping the fuel system functioning optimally. By understanding the roles of the MAF sensor, AF sensor, and overall system dynamics, vehicle owners can enhance the life and performance of their Honda Accord. Please like and subscribe to the channel. See you next time.